1 in 2 people face cancer in their lifetime. Almost every family on Earth has been touched by it. We've walked on the moon. We have mapped the entire human genome. We have built machines that can think. Why can we still not cure cancer? The answer is not a lack of effort. It is not a lack of money. It is not a lack of brilliant scientists. The answer is hidden inside the biology itself. Cancer is not one enemy. It is thousands of enemies bearing our own face. To understand why, we start with a simple question. What is cancer really? Let us travel back 4,000 years. Ancient Egyptian doctors wrote about strange growths. They described lumps that could not be cut away. They even tried to burn them out. And they wrote a grim final note. There is no treatment. The name cancer itself comes from the Greeks. Hippocrates looked at a tumor with spreading blood vessels. To him, it looked like a crab. The Greek word for crab is karkinos. That name survives to this day. For 2,000 years, medicine was stuck. Doctors believed disease came unbalanced fluids. They called these fluids humors. Cancer, they thought, was an excess of black bile. So they bled patients. They purged them. Nothing worked. It was not until the 1800s that surgery improved. Anesthesia let doctors operate without agony. Could finally cut tumors out cleanly. But many patients still died. When the cancer returned, then came radiation. In the late 1800s, scientists found invisible rays. Doctors realized these rays could kill fast-growing cells, so they aimed the beams at tumors. Radiation therapy was born, but it burned healthy skin along the way. Then came the darkest accidental discovery. World War I, a gas called mustard gas was used. Soldiers exposed to it had bone marrow destroyed. Doctors noticed something strange. Killed the fastest dividing cells first. So they wondered, "Can poison like this kill cancer?" That question led to the first chemotherapy. Humans have known cancer for millennia, but only in the last century we learn what it is. Your body is made of about 37 trillion cells. Every single second, millions of them divide. Each division copies the entire DNA inside the cell. That DNA is 3 billion letters long. Copying 3 billion letters is never perfect. Tiny mistakes happen constantly. Most mistakes are harmless. Most are fixed on the spot by repair systems, but a few slip through. The wrong letters accumulate. A cell can change. It can forget when to stop dividing. It can forget when to die. That is the first step of cancer. One bad cell does not make a tumor. The immune system hunts abnormal cells every day. Most mutated cells are destroyed before they grow. Cancer only wins when a cell slips past every defense. Now let us meet the real culprits. They are called oncogenes. These are genes that push cells to divide. Healthy cells, they act like a gas pedal. They speed up growth when the body needs it. But when mutated, the gas pedal gets stuck. Cell divides without ever stopping. The other culprits are tumor suppressor genes. These act like the brakes. The most famous one is called P53. It watches the DNA for damage. The damage is too great. It orders the cell to die. P53 is broken. The brakes are gone. Cancer is a cell with a stuck gas pedal and no brakes. Scientists call these the hallmarks of cancer. And there are many hallmarks. A cancer cell keeps dividing forever. A normal cell can only divide so many times. At the end of each chromosome, it's a cap called a telomere. Every division shortens the cap. The cap runs out, the cell dies. Cancer cells rebuild their telomeres. They become immortal. This is why cancer cells can be kept alive in labs for decades. The famous HeLa cells came from one woman in 1951. Cancer cells are still dividing today. They have outlived her by more than 70 years. It is the power of a cell that never dies. So what causes these mutations? In the first place, some causes come from inside us. Every time a cell divides, errors creep in. These are random mistakes in copying DNA. Aging itself increases the number of errors. The longer we live, the more chances cancer gets. That is one reason cancer rises with age. The causes come from outside us. Tobacco smoke is the biggest one. Smoking damages DNA directly. It is linked to more than 15 types of cancer. It causes nearly a third of all cancer deaths. Ultraviolet light from the sun damages skin cells. That is why sunburn raises skin cancer risk. Alcohol damages the liver and other tissues. Too much alcohol raises the risk of several cancers. Certain viruses can trigger cancer. Some carry genes that push cells to grow. Obesity changes the body's chemistry. Extra fat tissue can fuel tumor growth. A poor diet and lack of exercise add risk. Even some chemicals at work can be dangerous. Here is the hopeful part. A huge share of cancers could be prevented. Scientists estimate that nearly half are avoidable. Not smoking is the single biggest step. Protecting skin from the sun helps. A healthy weight and regular exercise help. Vaccines against HPV and hepatitis B help. Prevention is often more powerful than any cure. Some people are born with higher risk. They inherit certain broken genes from a parent. The best known are called BRCA genes. Broken BRCA gene raises breast cancer risk sharply. It also raises the risk of ovarian cancer. Inherited cancers are the minority. Only about 5 to 10% of cancers are inherited. Most cancer comes from mistakes made during life. Still, knowing your family history matters. It helps doctors screen earlier and catch problems sooner. Early detection changes everything. But the deeper problem is this. Cancer is not a foreign invader. It is made from our own cells. Virus or bacteria looks clearly different from us, so the body attacks it easily. But a cancer cell still looks almost like us. Every weapon we build against, it risks hurting healthy tissue. This is the first great wall we cannot easily climb. Now add the second wall. Cancer is not one disease. It is hundreds of different diseases. Lung cancer and leukemia share almost nothing. Even two patients with the same cancer have different tumors. Each tumor carries its own unique set of mutations. No single drug can fit everyone. So we cannot build one silver bullet. We would need thousands of bullets. And even that is not enough. Because a single tumor is not one enemy either. Inside one tumor live billions billions of cells. They are not identical. They are a crowd of genetic cousins. Some resist drugs. Some grow fast. Some hide from the immune system. When treatment kills the weak, the strong survive. This is evolution happening inside your body. Natural selection, but in fast forward. A drug kills 99% of the tumor. The 1% that survives now owns the field. It multiplies. Tumor returns, now resistant. This is why treatments that work first often fail later. Doctors call it drug resistance. It is one of the hardest problems in all of medicine. There is a third wall. Cancer does not stay where it begins. It learns to spread. This spreading is called metastasis. It is what turns a treatable lump into a deadly disease. Most cancer deaths are caused by metastasis, not by the original tumor. A cell breaks away from the tumor. It slips into the blood or the lymph. It travels to the lungs, the liver, the brain. There it sets up a new colony. By the time we see it, the cancer is everywhere. Surgery can remove one tumor. It cannot remove 100 hidden colonies. This is why early detection matters so much. Catch cancer before it spreads, and the odds change completely. Now the fourth wall. Tumors do not grow in empty space. They build their own environment. Scientists call it the tumor microenvironment. Cancer tricks nearby healthy cells into helping it. It grows new blood vessels to feed itself. This process is called angiogenesis. Tumor sends out chemical signals. They demand more oxygen and more sugar. New vessels snake toward the tumor like supply lines. The tumor also sends signals that calm the immune system. It builds a shield of scar tissue and confusion. Drugs struggle to even reach the cancer inside. This microenvironment is not an accident. It is a fortress built by the disease itself. There is a fifth wall. The immune system should be our best weapon. It was born to hunt abnormal cells, but cancer learns to wear camouflage. It raises a chemical flag that says, "Do not attack me." It exhausts the very immune cells sent to kill it. Some tumors even recruit immune cells to protect them, so our strongest defender becomes the enemy's guard. Scientists have spent decades trying to unmask cancer. They have made real progress. This is the part of the story we must not forget, because the honest answer to why we cannot cure cancer is this: we actually can cure some cancers. We have already done it. Testicular cancer was once almost always fatal. Today, over 95% of patients survive. Childhood leukemia was a death sentence in the 60s. Today, about 90%. Children are cured. Thyroid cancer and early skin cancers are highly treatable. Even some breast and prostate cancers caught early are beaten. So the real question is sharper. Why can we cure some cancers but not others? The answer comes back to those 5 walls. Some cancers are simple and slow. They have few mutations. They're caught before they spread. They stay in one place. These are the ones we can now beat. Other cancers are fast and messy. They mutate wildly. They spread before we ever notice. These are the ones that still defeat us. Think of pancreatic cancer. It hides deep in the body, shows almost no early symptoms. By diagnosis, it has usually already spread. That is why its survival rate is still very low. Think of glioblastoma, a brain cancer. Threads through the brain like roots. Surgeons cannot cut it all out. Drugs cannot fully reach it. Returns again and again. So the fight is not one battle. It is many different battles. Some we have won. Some we are winning. We are still losing. Screening means checking for cancer before symptoms appear. A mammogram can find breast cancer early. A colonoscopy can spot and remove precancerous polyps. Pap smear has flash cervical cancer deaths. A simple skin check can catch melanoma early. These tests have saved millions of lives. Screening works best when the cancer is slow, but some cancers have no good screening tests. That is why pancreatic cancer is found so late. Scientists are racing to build better tests. Blood tests that sniff out cancer early. Look for tiny traces of tumor DNA. These are called liquid biopsies. In the future, a yearly blood test may catch many cancers. That single advance could save countless lives. Now let us look at the weapons we have built. The oldest weapon is surgery. The tumor out before it spreads. For many early cancers, this alone is a cure. Second weapon is radiation. High energy beams shred the DNA of cancer cells. It is precise and powerful, but it can also harm healthy tissue nearby. The third weapon is chemotherapy. Poison that kills any cell that divides quickly. Cancer divides fast, so chemo hits it hard. But hair cells and gut cells divide fast too. That is why patients lose hair and feel sick. These 3 weapons have saved millions of lives. They are blunt. They cannot tell friend from foe. So science built sharper tools. These are called targeted therapies. They attack only the specific mutations a tumor carries. Imagine a lock that exists only on cancer cells. A targeted drug is a key that fits only that lock. Healthy cells do not have the lock, so they are left alone. It works beautifully when the lock is known. The first great success was a drug called Gleevec. It transformed a deadly leukemia to a manageable illness. Before it, patients had a few years. After it, most lived for decades. That was the proof. Targeted therapy works. Tumors evolve. They change the lock. Drug stops fitting. Resistance returns. So targeted therapy is powerful but not permanent. And then came the revolution. Immunotherapy. Instead of attacking the cancer, we wake up the immune system. One approach is called checkpoint inhibitors. They remove the camouflage cancer uses to hide. The immune system suddenly sees the tumor again. It attacks. For some patients with advanced cancer, the results are stunning. Tumors that would have killed in months simply melt away. Some patients stay cancer-free for many years. This work won the Nobel Prize in 2018. Another approach is called CAR T therapy. Doctors take a patient's own immune cells. They reprogram them in a lab to hunt the cancer. Then they return them to the body as living weapons. Some blood cancers, this is nothing short of miraculous. Immunotherapy does not work for everyone. Some tumors have no obvious flag to target. Some immune systems are too exhausted to wait, and the treatment itself can overheat the immune system. So even our best new weapon has limits. Then there are vaccines. Vaccines. We already have one that prevents cancer. The HPV vaccine protects against cervical cancer and other cancers linked to the virus. The hepatitis B vaccine prevents many liver cancers. These are true cancer prevention. The vaccine to cure an existing cancer is much harder because every tumor is unique like a fingerprint. Scientists are trying to build personalized vaccines. Each one is made for a single patient. Teaches the immune system to that patient's exact tumor. Early trials are promising, but this is slow, expensive, and still experimental. So where does all of this leave us? Future of cancer care is not one magic cure. It is a combination of every weapon. Doctors now mix surgery, radiation, and immunotherapy. They match the treatment to the tumor's exact mutations. This is called personalized medicine. It is working. More people survive cancer today than ever before. Death rates have fallen for decades. Some cancers have gone killer to manageable, but the word cure is still tricky because cancer can come back after many years. Patient may be cancer-free for 10 years then relapse. Doctors often say remission, not cure. A cure means it will never return. That is a high bar for a disease that evolves. Here is the most hopeful fact. We understand cancer better today than at any time in history. We can read the exact letters of a tumor's DNA. We can watch it evolve in real time. We are learning its tricks faster than it can invent new ones. Early detection is improving every year. Liquid biopsies may soon find cancer. A simple blood test. Artificial intelligence helps doctors spot tumors earlier. Every month new drugs and new combinations are tested. The pace of progress is accelerating. Clinical trials test new treatments every day. Thousands of patients volunteer each year. Their courage drives every breakthrough. Progress is measured one study at a time. The war on cancer is really 1,000 small wars. Each new drug is one small victory, and the victories are adding up fast. So the honest answer to the question is this: cannot cure all cancer yet, because cancer is not one disease, because it is made of us, because it evolves faster than our drugs, because it hides, spreads, and builds fortresses. We have not lost. We are winning one battle at a time. Someday cancer may become a chronic illness, something we manage rather than fear, something we catch early and treat precisely. That day is not a fantasy. It's already beginning.